Hey guys, it is the day one of a new unit. The new unit is going to be on quadratics, so it's an entire unit on parabolas. So we're going to graph parabolas, we're going to solve parabolas, we're going to relate parabolas to the real world. So you better get ready to do some squares. We're going to start off by graphing. I'm not here today, but you are going to still learn the lesson. You're going to learn it through this video. So if you've never done this before, my suggestion would be to take out your notebook and pretend that I'm there. This is exactly the same file that I would have used if I was in front of you guys right now. So, and this is the lesson. So if you don't get it, you can always, it's a video, so you can hit pause, you can rewind. I guess it's just going back. Take your time with it. Whatever the case may be, this is exactly what I would have done, so you're not missing a beat. And when I come back, we're going to just kind of pick up where we left off. So we're starting with parabolas. You're going to need your notebook. I would take that out and write all of this in your notebook. In order to get us started, though, we are going to review something that we did earlier in the year. And that is going to be us moving these, our absolute values, but the way that we moved them before is going to relate us to parabolas. So we're graphing parabolas today. That's the whole purpose of today's lesson. We're going to learn how to graph them. You might think that you already know how to do it, but we're going to learn how to shift them, which is moving them left, right, up, and down. And we're also going to learn how to kind of change their shape, widen them, make them skinnier, that type of thing. So let's first review how to move some of these absolute values. Now, an absolute value, if we remember, was a V shape. And from back in Unit 1, so it's been a little bit of time, we learned that these two numbers in this first example here kind of move things around on us. The 4 at the end is going to move a equation up 4. And in the parenthesis, or in the absolute value, things kind of work differently than what you would think. So if it's x minus 2, it's actually going, if you remember, to the right 2. So I would start at 0, 0. You can see my cursor right there at 0, 0. But we're going to move to the right 2. So 1, 2. And we're going to move up 4. 1, 2, 3, 4. So our point's actually now going to start at the point 2, 4. Now with absolute values, we just went with a slope of up 1 over 1 to the right and up 1 over 1 to the left. And there was our graph. If I look at the other example that I have, it's a new equation, still absolute value, but now this number at the end, if it's subtracting, it made our graph go down 3. The number in the middle is opposite than what you would think, so if it's x plus 1, you're actually going to the left 1. And this little negative outside is actually going to flip our graph, and instead of opening up with a V, we're going to open down kind of like a mountaintop. So we would normally start at 0, 0 again, but this is going to the left 1. You can follow my cursor, and down 3. So we're now going to have what we call the vertex at -1, -3. But instead of opening up, we're going to open down. So we're going to go down 1 over 1. And down 1 over 1. So what we need to remember from this is actually how to shift. How do we go left? How do we go right, up, and down? So let's relate that to parabolas. First thing that you have to know is you're going to hear some vocab from me. Transforming is to change the shape. Kind of think of Transformers, the movie. So we're going to change the shape from the original, like, standard graph, and translating is sliding it. I think you guys did a little bit of this in geometry last year. So that's going to go left, right, or up and down. So you haven't learned this yet, but there are actually two ways to write a parabola. You are familiar with one of the ways. It is ax squared plus bx plus c. We talked about it in the matrix unit, and you see it when you are using the quadratic formula. That is the standard form of a parabola. But that form doesn't really help us much when we're trying to graph a parabola. There is a better form in terms of graphing a parabola, and it's called the vertex form. And the reason why it's helpful and why it's better to graph off of the vertex form is because the vertex form of a parabola gives us where the vertex goes. And now if you think about back to where we were just on absolute values, we can kind of relate that a little bit to parabolas. So if I have an x squared, that's the beginning part of any parabola. If I add a number at the end, that moves my parabola up or down. If I move or add in a number in the middle, this moves my parabola left or right. Now, I don't know who came up with H and K, but those are the letters we use to represent them. They are not the same letters B and C because they end up not being the same number as B and C. Now, this A that you have in front of your x squared is still going to be in the vertex form. It's the only variable that's going to actually be the same number. And this is actually going to what we call either stretch or compress. So basically, those are two new vocab words for you. A stretch is going to make the graph skinnier. And that's the word skinny, by the way. And compression is going to make the graph wider. You're going to see that here in a few minutes when I'm done and we're starting to graph some things. But the reason why we like this is because vertex form gives us, just by looking at the equation, what the vertex is. It's going to be the point, the coordinate point that we get from our h value and our k value. Now understand that the h value is actually minus h. So whatever number this is after a subtraction sign is actually your h, and k is straight up as is down here in your vertex. This might sound weird because I don't have any equations yet, but we're going to start there. And we're going to learn how to graph right off of this vertex form. So that's the goal for today. Okay, so before we get to graphing them, I just want to kind of take a few parabolas and take a look at them. So if I look at this first one here, I'm just going to try to talk about how they've been moved left or right. This first one, if I have x minus 1, it's gone to the right 1. And this is going to go up 10 because it's a plus 10 at the end. I'm going to talk about the numbers out front in a second, okay? Because I haven't talked about that yet. I move over to the next one. We have x minus 2. So it's a negative. It's going then to the right, opposite what you think inside. And if I have minus 3 at the end, that's going to take me down. If I come down to this bottom one, I have x plus 3. That actually is going to take me to the left 3 units. And then the plus 1 is going to take me up 1 unit. And last but not least, if I have x plus 1, I'm going to go actually to the left 1 unit. And x minus 4 takes me down 1 unit. 4 units, sorry. So I haven't talked about what these numbers do out front. They are all a values. This first one is an a of 2. Then we have an a actually that's negative 1, 1/2, and then 1/3. So the first one that you actually kind of are probably familiar with is the negative. When we did absolute value, the negative turned our v from going up to going down. So this is actually going to do the same thing. It's going to flip. Instead of having a U shape, we're going to have almost what looks like an N, an upside down U. Okay, so the other ones are also A values. Now, I just mentioned the thought process before about stretch or compress. I'm going to go back to this page. When we stretch, that means a value is greater than 1. So 2, 3, 10. You can even go 100. But it's not just a whole number. I can have 3 halves. I could have, 12.5. That's kind of weird, but I can have any number itself that is bigger than 1. If you compress, you are actually going to have a number that is between 0 and 1, smaller than 1. And the reason why it's stopping at 0 is because the negative simply flips it. So I can't go down into the negatives because all the negative is going to do is flip upside down. So we're going to talk about what it means to stretch or compress our graph once we start graphing. So that means that this 2 is stretching. And the 1/2 is between 0 and 1, so that's a compression. And 1/3 is also between 0 and 1, so that's a compression as well. And we'll talk about that here as I start to graph them. So, look at this y = x² is the most generic parabola that you can have. So the vertex of that parabola is right there at 0, 0. Now, you're going to think that you can just draw a U shape up, whatever, good. That's what our parabola looks like, except that's not what we can do. We're going to be better than that. We're going to draw an actual pretty accurate sketch. And there's a pattern to graphing parabolas. You probably just don't know it yet. But if I come here off to the side, 1, 3, 5, 7, 9, 11, I just wrote a list of odd numbers. Well, that's actually your pattern for graphing parabolas, believe it or not. What I mean by that is you start at your vertex, you go 1 to the right, you go 1 up. You then go 1 to the right, and then you go 3 up. You go 1 to the right, and then you go 5 up. If I ran out of, or if I didn't run out of room, sorry, I would go over and I'd go up 7. Then I would go over and I would go up 9. I would go over and I'd go up 11. And that would continue on forever. So that is what gives us our curve. Now, if you understand this, kind of goes along with this line of symmetry, the parabola is symmetric. So if I can go over to the right 1 and up 1, that means I can also go over to the left 1, up 1, left up 3, left up 5, and so on. And now I have a parabola. Now, something you have to know about parabolas is they are symmetric, which means right here down the middle, I have a line of symmetry. And oftentimes we want to know what the equation of that line of symmetry is. So it is a vertical line. And if you recall from earlier in the year, we write vertical lines as just an x equals. And we get that value of our x. It goes right through our vertex. If you look, it's going to go right through the vertex. So just grab the x value from your vertex and you have your line of symmetry. So the question is, how do we move this, and how does this change when I start to shift things around? So if you look at this next one, I have a little bit of a shift. I am going, if you look at this last end, I'm going to go down 1. And I'm also, if I have x minus 1 in here, I'm going to go to the right 1. So I would normally start at 0, 0, but I am going to the right 1 and down 1. So now 1, -1 is my vertex. So if I ever ask you, hey, what's the vertex? You can pick it out from, remember, here's your H, here's your K. So that gives me my vertex. This is my H value, this is my K value. So right away, I actually know that 1, -1 is my vertex. So if I'm graphing this, I'm actually now starting at this 1, -1. So I'm going to follow my 1, 3, 5 pattern from this point now. So from where I am, I'm going to go over 1, up 1, over 1, up 3, over 1, up 5. And what I do over here to the right, I can do the same thing to the left. There we go. And our axis of symmetry is going right through there. And if I look at my x-coordinate of my vertex, the axis of symmetry then is going to be at x equals 1. Okay? So once you know where you have shifted and how your graph has changed, you will then just go shift to that point and then graph your 1, 3, 5, 7 pattern that we had, this pattern over here, and you can plot your points. And it actually looks like a real parabola instead of just as a crappy sketch that you guys can get, that we all can get, okay? So, what do stretches and compressions do? Okay, I try to keep this easy so I didn't shift them at all. Notice they're both just x squared. So we're starting at x squared. So this number that you have in front is actually your stretch factor, which is any number bigger than 1. So that's this first example. Or a compression factor, which is between 0 and 2. I'm sorry, 0 and 1. So we are stretching, in this case, in my example, by a factor of 2. So we're going to be twice as steep every time. So when our normal pattern was 1, 3, 5, 7, 9, etc., we're twice as much as these. That's what this means. You're going to take your number and multiply it by 2. So we're going to have 2, 6, 10, 14, 18. Okay, what that means is instead of going over 1 and up 1, we now go over 1 and up 2. Then from there, we go over 1 and now up 6. 1, 2, 3, 4, 5, 6. And you see why it makes it skinnier is because you're going up faster. So it makes your graph skinnier than your normal one. I'll draw in the normal one just so you can see. It's a little bit wider, if you notice. So I'll erase the red then in a second. But do you see how the blue is skinnier? It stretched it, so it's skinny. I think S and S. Okay. I'll erase the red, though, so you kind of were just looking at the blue one. All right, so you take your 1, 3, 5, 7 pattern and multiply it by your stretch factor, and that's how much you're now going to go up. Same thing works for compression. I start at 0, 0. I would have gone 1, 3, 5, 7, 9. Now this is the one that's kind of strange and a little bit hard to do at times. We're going up and we're multiplying by 1/2. So we're actually going to go up by 1/2, 3 halves, 5 halves, 7 halves, 9 halves. So you'd still take your number and multiply by your pattern, your normal pattern of 1, 3, 5, 7. So when I'm graphing it gets a little challenging, but I'm still always going over 1. Every time I talk about my pattern, we're going to go over to the right 1 or over to the left 1. But now I'm going to go over to the right 1, and I'm only going to go up 1/2. Okay. Now, I'm going up 3 halves from where I was. So when I go over 1, I'm going to go up 3 halves from that. So here's 1/2. Here's a whole. And that, if you think about 3 halves, it's 1 1/2. It's like a little dot right there. Okay. Now I'm going to go up 5 halves. So from where I was, well, 5 halves is 2 1/2. So I'm going to go over 1, up 2 1/2. 1, 2 1/2. And I can graph a pretty accurate parabola. So 7 halves is 3 1/2. So I'm here. I'm going to go over my 1. Okay, so now I'm going to go up 3 1/2. So here's the half. 1, 2, 3. And do you see how you're not going up by as much every time? This is why this one gets wider, because you're not going up as steep or as much every time. So it kind of gets a little bit wider than your normal. I'll draw in the normal again. The normal is here. So see how that's going to be wider than the normal. And this back one, actually, I'll put it back on there, is skinnier than the normal. Just do the one side of it. Okay, so you're going to get the packet for the unit. take out your packet, and we're going to look at the very first problem. So this is what I want you to do with the packet, and we're going to draw this. A lot of it's just taking a look at your equation and seeing where you can go from there. So I'm doing the first one with you, and then we're going to talk about it again when I come back to class tomorrow. So here we are, x plus 9 quantity squared. So this moves my parabola left 9. I did not go up or down at all. So if my vertex is normally at 0, 0, and I go to the left 9, that means just by looking at my equation, I can tell that my vertex is at the point -9, 0. Okay, this up or down part means, is my parabola going to be opening up or opening down? And that's all based upon if I have a negative out here in front. I do not, so I am not opening up. I am opening up, sorry. I'm not opening down. I'm not flipping. Okay, is this graph stretching, compressing, or not doing anything? Well, I look at this front part in here. I don't see a number at all, so it's going to do neither. Okay. So I want to graph this now. It's best to find domain and range off of a graph. So I'm going to go ahead and graph this. So if I went over 9, I'm starting my vertex right here at -9, 0. I'm not stretched or compressed, so I'm going to go by my pattern of 1, 3, 5, 7. So I'm going to go over to the right, up 1, over to the right, up 3, over to the right, up 5. Now, this is not a very good accurate. I think you guys have a better one than I do, but my other side kind of goes off this graph right here. So now I have it graphed. So now we're going to go back and do domain and range like we did from the first unit. If I look at all of the values of x, I can put in any value for x and square it. So my domain is going to be all real numbers. So if you remember how we write that, we go -infinity to +infinity. And then range, if you take a look at your range, the lowest this graph goes right here is the x-axis. So the lowest I go is 0. I am going to go on forever, so I'm going to go up to infinity. Infinity, you can never equal, so it's always parentheses. So the question is, are you parentheses or brackets for this 0? And if you look at your graph, you do come down here and touch it, which means we can include that 0, so we put a bracket around it. So this homework that you guys are going to have is meant to do without a calculator. You're going to just have graphing. You're going to just look at an equation, try to answer, circle these questions. Are you moving up, left, right, neither, stretch, compress, whatever the case may be. Tell me what the vertex is and try to graph it using your pattern of 1, 3, 5, 7, 9. I am going to tell you that for this test as well, this unit, you are going to have some no calculator stuff. So just be aware that you're going to have to be familiar with it. We are going to do some stuff with the calculator, but I want you to get used to them now as well. If you need to go through things again, just hit pause or go back and listen again. I will go through a couple of things on Monday as we do this again. If you have any questions, please feel free to come in and ask. Come in during resource ask. I'll be here. Hope you guys have a good day.